we have to separate into partial fractions. So first we need to check the power of numerator and denominator. In numerator we have only 1, so the power of x is 0, and in the denominator we have x to third power, so the power of numerator is less than denominator, so everything is okay. Next we have to factorize our denominator. So numerator we copy, we will factorize x squared, so we will have in parentheses x plus 1. So we see that we have repeated linear factor x 2 times. So now we will have in denominator x to first power, we don't have to write. Next we have x to second power, and the last is x plus 1. Always when we have to rewrite our original fraction to partial fractions, when we factorize our denominator, the denominators of our partial fractions are the factors of our denominator. And in this example, because x is to second power, it means x repeats 2 times. It means first we have x to first power and next x to second power. If we have here x, for example, to fifth power, we need to have first x to first power, next x to second power, x to third power, x to fourth power, and x to fifth power. And at the end will be x plus 1. And now, because the factors are linear, so the numerator is constant. So will be a, b, and c. And now we need to find a, b, and c. They are our unknowns. So let me copy one more time our example. We have 1 over x squared times x plus 1. This is equal a over x plus b over x squared plus c over x plus 1. First, we have to get rid of our denominators. How we do this? We have to multiply both sides of our equation by the lowest common denominator. What is the lowest common denominator? Is always the denominator of the original fraction. So it will be x squared times x plus 1. Whole right side we have to multiply. We see that x squared will reduce with x squared, x plus 1 with x plus 1. So on the left side we will have only 1. This is equal. And now on the right side we have to multiply every fraction by x squared plus x plus 1. When we multiply first fraction by x squared, x will reduce with square. So we will have only a times x and times x plus 1. Plus, next, the second fraction when we multiply by x squared and x plus 1, x squared will reduce with x squared. So we will have only b times x plus 1. And the third fraction when we multiply by x squared and x plus 1 will reduce and we will have only c times x squared. So now we have to do multiplication on the right side. Left we will copy. We have ax times x, so it will be ax squared. Ax times 1 is ax plus b times x is bx, b times 1 is b, plus cx squared. Next we have to combine the like terms. Left side we will rewrite. We have ax squared and cx squared. So we have a plus c times x squared. Next we have ax and bx. So we have a plus b times x, and at the end we have constant b. Left side must be equal to the right side. What it means, we have to compare the coefficients. On the left side we don't have x squared, so it means the coefficient of x squared is equal 0. So it means that a plus c must be equal 0. So next, we don't have x on the left side again, so the coefficient is 0. So a plus b must be equal 0 and constant b must be equal 1. We have b, So when we have B, we have three equations, three unknowns, so everything is okay. B we found, so now we will find the A. We just substitute B by 1, so this is equal 0. So we have that A is equal, I will move 1 to the right side, so it will be negative 1. We have A, and now we can find C. A is negative 1, so negative 1 plus C, this is equal 0. So we have that C is equal negative 1 to the right side, so it will be 1. We found A, B, C, so now we can write our original fraction into sum of partial fractions. So let me copy. We have 1 over x cubed plus x squared. This is equal a over x. A is negative 1, so we have negative 1 over x plus b is 1 over x squared. We copy, plus c is 1 over x plus 1. This is my solution.